All right, we're going to do some interest skills practice here, and we're going to run through some problems using our formulas as we go. So here, number one, we're going to find the balance and interest on each of the following. So balance is principal. Well, we've got $3,500 deposited. $3,500 is my principal. 1 plus the rate. Well, here's my rate, 1.5%. So 0.015 divided by how many times a year do I compound? Well, compounded quarterly. Quarterly means 4 raised to the, well, 4 times a year for 6 years. And those get multiplied together. So you might want to start, I know some people like to maybe combine their exponents and have 24 because 4 times 6 is 24. That's fine. Either way you look at it, at the end you should have a balance. So your balance is 3828.97. Now to find your interest, you take your balance minus your principal. How much did you start with? And in this case, our interest would be $328.97. Number two, we have $475.18 deposited at 2.65% compounded monthly for 18 months. Okay, so my balance is principal times 1 plus the rate as a decimal. Monthly means 12, raised to the 12 months a year for 18 months. Now, 18 months is 1.5 years, because remember, our time is always in years. That is a multiplication dot. When I get this, I end up with a balance of $494.43. My interest, I take $494.43, subtract $475.18, and my interest is $19.25. So there's my two pieces. Number three, I have $12,750 deposited at 3.8% compounded weekly for 4 years, 6 months. Okay, so that's 4.5 years. Weekly means 52, and as a decimal, this is 0.038. So my formula, balance equals principal times 1 plus the rate divided by the number of times I compound raised to the 52 times 4.5 power. All right, when I get that, I end up with a balance of $15,126.81. To find my interest, I start with my balance, I subtract my principal, and my interest in this case is $2,376.81. Not bad for just leaving it in a bank account, right? Not bad at all. Number four, we've got $600.73 deposited at 4.6% compounded daily for 2 years. All right, so T is 2, N is 365, rate is 0.046, and here is my principal. So my balance is principal times 1 plus the rate divided by 365 raised to the 365 times 2. And I hope you're okay on putting that little caret piece in there. That is a button that you might use on your calculator, but just so you're aware. And therefore my balance, when you plug that into your calculator, $658.62. To find my interest, I take my balance, I subtract my principal, that's correct, and when I subtract those, I end up with $57.89. Number five, I've got $1,045 deposited at 3.25% compounded monthly for 36 weeks. Now, 36 weeks. There are 52 weeks in a year. So my T is the fraction 36 over 52 because T is always in terms of years. So this is part of a year. Monthly, and it's 12. My rate is going to be 0.0325 because you got to change that to a decimal. So in my formula, I've got principal, 1 plus the rate, divided by n, right, number of times you compounded, raised to the 12 times the fraction 36 over 52. And that's fine, right? That's like 12 over 1. You can do that in a calculator without a problem. So your calculator should spit out for you $1,068.75. Now to find my interest, I take my balance, I subtract my principal, and I end up with $23.75 for my interest, right? It's less than a year. 36 weeks is not even a full year. So just over half a year, and you've got yourself $23 in interest. Okay, now we're going to do this problem, $4,200 deposited at 2.76% for 5 years, compounded annually. So first things first, balance is principal times 1 plus 0.0276 annually is just 1 raised to the 5.1 power. Now that gives me an answer of 12 and 49 cents. That's the balance. The interest, when I subtract my balance minus my principal, I get 612.49. Okay, now recall in simple interest, interest is principal times rate times time. So I take 4,200 times my rate, 0.0276, times 5. And I get an interest value of $579.60. This is interest. All right. Well, if I started with 4,200 and I'm going to add my interest because this is good interest, my ending balance will be $4,779.60. Okay, now we want to compare the two balances. Part C says how much more interest was earned. Well, I guess we can either compare ending balances or just interest. If I take 612.49 and I subtract 579.60, I find out that $32.89 more interest is earned by compounding annually versus simple interest. So you definitely want simple interest if at all possible because you will earn more over time. Right, you're compounding more. That's the way it works. All right, number 7. Carolyn wants to ensure that her son has enough money for his first year of college. Good luck, Carolyn. So she starts an account for him when he's born. If she deposits $1,500 into an account that pays 3.75% interest compounded weekly, how much will be in the account when he turns 18? Okay, so she's not doing anything else. She's putting the money in, she's letting it grow. So balance, principal, 1 plus the rate as a decimal point, 0.0375. It said weekly, so we're dividing that by 52. And then our exponent will be 52 times 18. 52 times a year, and it's for 18 years. So when her son graduates from high school and gets his college money, he will have $29.45.33, almost double what she started with 18 years earlier. And that might pay for the first semester depending on where her son goes to school. All right, number 8. If you deposit $3,000 into an interest-bearing account today, how much money will be in the account in 18 months if it pays 2.25% compounded monthly? All right, so balance is principal times 1 plus the rate divided by how many times are we doing this? Monthly is 12, raised to the 12 times 1.5 because 18 months is 1.5 years. So when I do this, I end up with $3,102.88. So after 18 months, you will have earned $102.88 in interest. If the problem in number 8 were compounded daily, okay, so remember that problem, we had a principal of $3,000, we had a rate of 0.0225, and our time was 1.5 years. Okay, so we go, balance is principal times 1 plus the rate, but now we're compounding daily. So now we're dividing by 365, and our exponent is now 365 times 1.5. This balance gives us 3102.97, where the last one was 3102.88. So you're earning 9 extra cents. And you might say that's not very much. Well, it's no extra time. The only difference is how many times you compounded. And this is just $3,000. Imagine if you had an account that had $40,000 in it, right? Then you might see a more significant change, but that's whatever. Who has $40,000? All right, number 10. During his lifetime, Vincent Van Gogh sold only one painting, The Red Vineyard, for 400 francs. It sold just before his death in 1890. There's a little bit of history for you. In part A, Van Gogh had deposited the 400 francs in an account paying 5% compounded semi-annually. So that, oops, wrong button. So that means twice a year. What would the amount be in the account now? All right, so balance, principal is his 400 francs, plus 1 plus the percent is 5%, compounded semi-annually. We're going to raise that to the 2 times, oh dear, how many years do we have? Well, we're in 2016, he sold it in 1890, we're talking about 126 years. Okay, so we're multiplying 2 times 126, right, because that's T. When I plug that into my handy-dandy calculator, I end up with 201,592.36 francs. That's quite a bit more than the 400 he started with, right? But 5% is a hefty rate. You won't find that anywhere right now. And 126 years is a long stinking time for money to just be growing and growing and growing without people taking anything out. Now, what if the account paid 4.5% compounded quarterly? So we're still talking about 400 francs. 1 plus 0.0475. Quarterly means 4. And we're going to raise that to the 4 times 126 power. So if that's the case, there would only be 153,461.88 francs. So you can see you compounded more often, but look at that 0.25% interest rate. So you might think, oh, 0.25% here or there, that doesn't matter in terms of a car loan or a house loan, but 0.25% can add up to a lot of money over time. And the last problem, assuming that the 400 francs is about 1,500, how much would be in the higher paying account in today's currency? Well, the higher paying account was part A, where our rate was 0.05, our N was 2, and remember, time is 126. So let's go ahead and figure this out. If my principal is 1,500, 1 plus 0.05 divided by 2, and then raised to the 2 times 126 power, we're talking $755,971.35. Right? That's a chunk of change. I'd take it. I'd take it right now. I got to sign something. And that is your work, I believe. Yep, with interest.